Today we're going to work through question 1 on the limiting and excess reactant worksheet. We're going to utilize something called a BCA table. You'll see it right below the balanced chemical equation, and that's to keep track of the amount of moles before the reaction takes place, the amount of moles consumed during the reaction, and also the number of moles that remain after the reaction has gone to completion. So I'll help you determine what to put where in there and how to help keep track of all of your information. So let's get started on our problem. If I start with 25 grams of lead nitrate and 15 grams of sodium iodide, how many grams of sodium nitrate can be formed? So we're given our starting amounts of each reactant, and we want to convert to grams of sodium nitrate. Now our first step is to determine which reactant is going to run out first. So remember, the limiting reactant is the reactant that determines the maximum amount of product that can be produced. So for our BCA table, we want to write both of our amounts of reactants in terms of moles before the reaction occurs. So let's take our amount of grams given in the problem and convert that to moles. We'll utilize the molar mass to help us with this quick conversion. So let's do lead nitrate first. We have 25 grams present in the reaction, and when we divide by its molar mass of 331.22 grams, we get a total of 0.0755 moles. Next, we'll convert our grams of sodium iodide to moles. So we're starting out with 15 grams of that reactant. We'll divide it by its molar mass of 149.89, and we end up with a total of 0.1 moles. So in our BCA table, again, this is the amount of moles that we have before the reaction has started. So I've filled in the appropriate amount below both reactants, and then our product, we haven't produced any product yet because the reaction has not started. So I went ahead and put 0 moles under sodium nitrate. You'll also notice that I blacked out lead iodide in the BCA table, and that's just because this problem is not asking anything about lead iodide. So you can cross it out or just leave it blank on your end if you want to. Our next step is to use the molar ratio to determine limiting and excess reactant. So for me, I always like to try to take an educated guess at which reactant will run out first. So let's start with moles of sodium iodide and convert that to moles of lead nitrate. So when we do that, if we start out with our 0.1 moles of sodium iodide, we'll copy and paste that unit and substance down diagonally. And then on top, we want to convert to moles of lead nitrate. So if we look at our balanced chemical equation, you'll notice that for every 1 mole of lead nitrate, there's 2 moles of sodium iodide. So when we multiply across the top and divide by the bottom, we end up with 0.0500 moles of lead nitrate. So we need to analyze this statement. What this is saying is if I start with 0.100 moles of sodium iodide, then I need 0.0500 moles of lead nitrate. So this is essentially what we need to have, and we can look up in our BCA table to determine the actual amount of moles that we are starting out with. So we actually have 0.0755 and we need 0.0500. So what that tells me is that I have more than enough. I have excess lead nitrate, if you will. So if we know that we have more than enough lead nitrate, that indicates that sodium iodide is our limiting reactant in this problem. So in order to determine grams of product produced, we need to start out with the amount of limiting reactant, which is sodium iodide in this case, and convert that to amount of sodium nitrate. So here's step 3. We're going to use our molar ratio to determine amount of product made. So we're going to start out with our 0.1 moles of sodium iodide, and then we're going to convert that to moles of sodium nitrate, our desired product. Looking at the balanced chemical equation, you'll notice for every 2 moles of sodium iodide, there's 2 moles of sodium nitrate that are produced. So those 2's, since it's a 2-to-2 ratio, they end up canceling out, and what that tells me is that we end up producing 0.1 moles of sodium nitrate. So we'll go ahead and plug that into our BCA table. So after the reaction has come to completion, we have 0.100 moles. Now, the question ultimately asked for grams of sodium nitrate, so we can do a quick mole to gram conversion that you'll see at the bottom right-hand side of the screen. So we have 0.1 moles of sodium nitrate, we have moles of sodium nitrate on bottom, and then grams of sodium nitrate on top. So when we have grams over mole, remember the molar mass in grams is equal to just 1 mole, and the molar mass of sodium nitrate is 85.01. So when we multiply across the top and divide by the denominator, we end up with a grand total of 8.5 grams of sodium nitrate being produced. So that would be our answer to number 1. Moving on to number 2, we want to know which reactant is the limiting reagent in the reaction described in problem number 1. So remember, thinking back to the step 2 that we did for number 1, we determined that we had more than enough lead nitrate for the reaction to be carried out. So the limiting reactant in this case is sodium iodide. In the moles consumed portion of the BCA table, you'll notice that we used up all of the 0.1 moles of sodium iodide, and that's because it completely ran out. Once you run out of one of your reactants, no more product can be produced. Number 3, how much of the excess reactant will be used during the reaction in problem number 1? So we want to know how much of that reactant will be used. Well, we actually already know this amount because when we were determining the limiting reactant, we converted moles of NaI to moles of lead nitrate. And when we did that, we determined that 0.0500 moles of the lead nitrate will be consumed or used up during the reaction. So we can go ahead and list that here. We have 0.500 moles. If we want to also write that in terms of grams, we could. We'll take our number of moles of lead nitrate and multiply by the molar mass, which is 331.22 grams, and that would show that we have 16.6 grams of lead nitrate that are being used up in the reaction. Now, to determine how much of the excess reactant is left over, we'll take the amount of moles we had before and subtract it from the amount of moles consumed during the reaction, and that leaves us with the moles that remain after the reaction has gone to completion. So when we have our excess reactant, lead nitrate, we started out with 0.0755 moles, and we subtracted the 0.0500 moles that are used up during the reaction. That leaves us with 0.0255 moles of excess reactant. That is left over or extra. Similarly to our last problem, we can also convert this from moles of lead nitrate to grams by multiplying by the molar mass, and that gives us a grand total of 8.45 grams of lead nitrate. Additionally, if you wanted to go back to the original starting amount of 25 grams that the problem gave us, and if you know we use 16.6 grams, You could also determine the amount that remains unused from that math as well. So that's kind of a second option for you. So hopefully that helped get you started on this practice. And if you have any questions, as always, please reach out to your teacher. Have a great day.